Okay, so we are going to look at one final skill you need to know in your TI-Nspire calculator, and that's using the inverse normal function. And it's related, you see it a lot in normal distribution questions. So let's look at a question that will kind of motivate our desire for this feature. And we'll talk about what this feature does. So let's look at example 1 on your screen. We have a normal distribution with mean 13 and standard deviation 1.4. And then the last thing it tells us is that for some data value a, the probability that our continuous random variable is less than a is 0.65. So here we know the probability. Using the normal CDF feature on our calculator, we would know a and find a probability. Here we have the opposite. We have a probability, 0.65, and we need to find the value of a that gives us that probability. And so our calculator has a function for this. It's located exactly with all of the other distribution stuff, probability distributions. This one's called inverse normal. And when you click it, it has all the information you could possibly want to give it. So the area is 0.65, our mean is 13, and our standard deviation was 1.4. And it says, oh, A is 13.5. So A equals 13.5. And what that means is if X is less than 13.5, the probability of that occurring is 0.65. And finally, let's look at a very similar problem. Here, we consider a normal distribution. Again, same normal distribution. The average is 13. The standard deviation is 1.4. And now the question tells us the probability that X is greater than some B value is 0.11. This is a very, very similar problem to problem 1. And the one catch is that when you use the inverse normal feature on your calculator, it assumes that you're giving it an area to the left of the point you're looking for. So in question 1, the probability that X is less than A is 0.65. That 0.65 is an area to the left of A. Here we have an area to the right of B, that is 0.11. But you probably remember that the probability that X is less than B is just 1 minus the probability that X is greater than B. Because altogether, the probability X is less than B plus the probability X is greater than B equals 1. In this part, the probability that X is greater than B we know, right? So the probability that X is less than B is 1 minus 0.11, which is equal to 0.89. So now we can use inverse normal with an area of 0.89 to solve for B. So let's do that. Zero 0.89, 13, and I always forget the standard deviation, 1.4. Here, B is equal to 14.7. So inverse normal, very straightforward to use. You just need to remember it's expecting an area on the left of the endpoint you're trying to solve for. And if you have an area on the right, you can subtract it from 1 to get an area on the left.